This is the fifth lecture of Chapter 8, and we finished off the previous lecture talking about the different groups, metals, nonmetals, the metalloids or semiconductors. And so now we're heading into talking about the organization of the periodic table. Now, before I get into this, one of the things that everybody talks about or asks me when we get to this part is, do I need to memorize the elements on the periodic table? Do I have to memorize this whole table? And the answer is no. All right, you are going to have that copy of the periodic table available for the exam. So make sure, since you won't be with me, make sure that you have a copy of it printed off or you have a copy of it saved to your desktop before exam 3, because you need to have that in order to work on the exam. And the exam will be in a locked browser, which means you won't be able to access another web page like PantherLearn to get to your periodic table. So make sure that you've either printed that off or downloaded it beforehand. Now, what you do need to do is understand the organization and the layout of the periodic table and how to use the periodic table, because we're going to be using it from here on out in the semester. So you'll need to be able to use the information and understand why it's laid out the way it is. Okay? So, all right. So, organization, the first thing I want you to just take a look at is look at the periodic table. Look at the periodic table. I don't know if you've ever looked at it and thought about it, but why didn't they just make it a giant rectangle, right? Instead, it's got kind of like this little castle motif going on, right? It's got towers on either side, but the towers aren't equal. These two rows down here we'll talk about, they actually go here. So this part of the table is actually supposed to be split, and those rows go right here in between. So the reason why they do that is in order to put this all on one page. It's easier to just put it down here. Otherwise, this page would have to be twice the length in order to be able to fit those rows in. So let's take a look at what's going on here. So as far as terms for the periodic table that I'm going to start using and you'll see in different places, period, and this is the periodic part of the periodic table. Periods are the horizontal rows on the periodic table. So they are numbered 1 through 7. I'm going to be flipping back and forth a lot in this part of the lecture. So if we go back over here, you'll see along this side, we've got 1 through 7. These two guys down here are in row 6 and row 7, because you can see they go right here. So 1 across, 2 across, and so on. So those are the periods. Then you've got families. Families are the columns, so the up and down sections of the table. Sometimes you'll see them called groups, or they'll be labeled as groups. Family and group means the same thing. And the thing is all of the elements in a family have similar properties, with one tiny exception, and I'll talk about that when we get to it. So if we take a look here, we've got a periodic table again, so I don't have to flip back and forth. So we've got our periods going horizontally. We've got our groups or our families going vertically in those columns. So we've got group 1, group 2, group 3 is over here, and you may be going, wait, why did you skip? Well, so there's actually 2 groups. So we've got representative elements is what makes up group A. And if you look along the top here, we've got 1A, 2A, and then if you skip over here, here's 3A, 4A, 5A, 6A, 7A, 8A. Okay, so these are what we consider what we call the representative elements. Basically, these guys they don't belong with the rest of the guys here in the middle. These elements here in the middle this whole block is what we call the transition elements. So the transition elements are group B, and we treat them for our purposes as one big group. So we're not going to talk about these guys as individual columns or individual families. We're just going to talk about them as one group or one family. Okay. So that's why we've got those two different letters with the numbers for the groups or families. Now the groups do have traditional names, and we're going to go through these different groups so I can talk to you about them a little bit. So you just saw the group B is the transition metals. So we're going to talk about the alkali metals, the alkaline earth metals. There's a whole section over here, 3, 4, and 5A don't have any traditional names. Then we've got the chalagens, the halogens, and the noble gases. So they do, for the most part, have traditional names, and these names are actually generally based on their properties that are very similar. They do react in similar ways to each other in these families or groups. So we're going to start off with our alkali metals. So these guys are 1A. They are the far left hand column. So we're talking about things like lithium, sodium, potassium, rubidium, cesium, and francium. So here are what these guys look like. You can see they all look very similar to each other. These guys have something in common. Like we said, all of the families have things in common. They all have one outer electron. What we mean by this is in their outermost shell, they only have one electron hanging out there. So for example, and we'll get into this in more detail later, but lithium, you can see lithium has 3 as its atomic number. So if we were to draw lithium with its shells, and there's its little nucleus in the middle. Remember, shell 1 can hold 2 electrons. 2. So there's 2, and because we're going to assume that lithium is neutral, that means lithium only has 3 electrons. So it's going to get 1 more in that shell, and no more, even though this shell can hold 8. Okay, the same is true for sodium, because this shell can hold 2, so we got 2. Then the next shell out can hold 8 plus 8. And then the next shell out will hold 1. So it would be 2, 8, and then 1 in the next one out for sodium. Like I said, we'll talk more about that here in a little while. So you can see from the picture that these elements, these alkali metals, are shiny. They are low density and soft. So you can actually just make a mark with them for the most part with your fingernail. These are not tough metals. I have seen people cut sodium with a butter knife. They are not really horribly tough metals. You can see that francium is radioactive. It's actually in this picture, it's actually still in an ore. You can't actually easily get it as its own individual element. The thing is, with alkali metals, they react violently with water. And when I say violently, that's what this picture down here is about. This is one of the lower number metals. It's either lithium or sodium, and this is just a dish of water with a small piece of one of these metals it's been dropped into, and so they will set fire. They will explode. They do not react well with water. I've seen demonstrations where they've taken chunks of sodium and chucked them into trash cans, and the entire trash can explodes. So I do not recommend trying that at home. These metals As you can see, these guys down here, cesium and rubidium, are definitely encased in different material. These metals are going to be stored in oil so that they don't react with water even in the air. They are free elements that are not found in nature. I'm sorry, their free elements are not found in nature, meaning that in nature you're not going to find just free sodium. It's going to be bound to something like sodium chloride. They are so reactive that as soon as they run into another element that they can react with, they will. Sorry about that. Now, hydrogen is in this column. It is in this family. However, it's not considered an alkali metal because it only has one single outer electron if it has one at all. And remember, hydrogen can act as a nonmetal or a metal, and usually it's going to act as a nonmetal. It's going to be a gas. All right, the next column over, 2A, this is the alkaline earth metals. So these guys are going to have two outermost electrons. So if we look at the periodic table, we can see that we're looking at this column right here. So beryllium, magnesium, calcium, strontium, barium, and radium. I bet you can guess that radium is radioactive. So if we take a look at beryllium, beryllium has an atomic number of 4. So if we do the same thing again, we've got our, I know it looks like a very sad egg. So we've got our nucleus. We know that this first ring can hold 2, and the next one can hold 2. And so that is 4 for beryllium. So the next one up would be, let's see, it would be 12. So that would be 2 plus 8 for the next ring, plus 2 in the next ring out. And so it's the same one if you do the math for them. Each of those elements is going to have that same pattern ending with 2 outer electrons in that outermost ring. These guys are also going to be reactive. They are going to be soft on their own. Again, generally not found very often as their own individual metals. Some of these, like when I listed them off, may have sounded familiar, like magnesium and calcium. Barium might have sounded familiar. Some of them are ones that we need. Alkali earth metals are interesting as far as why they're called alkali earth metals. So earth actually is talking about like non-metal, which is interesting because we now know they're metals. So they're called alkali earth metals because they don't melt or change in fire. And so that's why they got the earth name. The alkali part is actually related to them creating alkaline substances, which actually we use to make soap. We used to make soap. All right, so we're just traveling across the table. You may have noticed that. So we're going from left to right. So the next section is that chunk, the B families. So just going to talk about them as a whole group. These are the transition metals. The reason why we treat these guys as the same kind of group is because they have variable charges, meaning they have variable numbers of outer electrons. They can have anywhere from 1 to 3, and some of them actually, like for example iron, can have different versions of it. So it can have a 2 or a 3. So yeah, they're kind of weird. So these are pretty much all structural metals. So we use them. These are things like zinc, silver, gold, lead. They're all in that group. And these guys are going to be used as structural metals because they don't really react with water. They will react a little bit, but not much with water compared to things like the alkali earth metals and the alkali metals. And they are going to be hard metals. So if you think about if you've ever worked with zinc or anything like that, they are going to be much, much harder. And so if you take a look at your periodic table, you'll be able to find some examples of these. And we'll pick up with the next part of the table in the next lecture.